In this video, I'm going to go over the practice on identifying the probability statements using the addition rule. But before I go over question number 1, let's recap the formulas you've learned on the video lesson embedded in this week's lesson. I'll be focusing on the last two formulas, the multiplication rule and the addition rule. The multiplication rule states that the probability of A and B is equal to the probability of A times the probability of B. Now this symbol means intersection, meaning we're looking for the probability of event A and event B. Now the multiplication rule is only applicable when we know that the two events are independent. So we simply multiply the probabilities of A and B. For addition rule, it states that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now let's take a look at question 1. The scenario is, when a car is brought to a repair shop for service, the probability that it will need the transmission fluid replaced is 0.38. I'm going to refer to this as event A. The probability that it will need the brake pads replaced is 0.28. I'm going to call this event B. The third information we're given is that the probability that it will need both the transmission fluid replaced and the brake pads replaced is 0.16. So this is the probability of events A and B. We're asked to find the probability that a random car either needs the transmission fluid replaced or needs the brake pads replaced. So in this case, we can use the addition rule that says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Just plugging in those numbers that we have 0.38 plus 0.28 minus 0.16. That will give us 0.50 or simply 0.5. So our answer is 0.5. Let's take a look at question 2. Kelvin will soon be taking exams in physics and French. He estimates that the probability he passes the physics exam is 0.80. I'm going to call this event A. The probability that he passes the French exam is 0.85. I'm going to refer to this as event B. He is also willing to assume that the results of the two exams are independent of each other. We're asked to find the probability that Kelvin passes both of the exams, meaning passing the physics exam and the French exam. Since they are independent, the two events are independent, we can use the multiplication rule. The probability of A and B is equal to the probability of A times the probability of B. Plugging in those values, 0.80 times 0.85 will give us 0.68. So our answer for the first question is 0.68. The second question, we're asked to find the probability that Kelvin passes at least one of the exams, meaning passing the physics exam or the French exam. In this case, we can use the addition rule. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So we need the value 0.68 for this problem. Probability of A is 0.80, probability of B is 0.85, minus the probability of A and B, which is 0.68. And we'll end up with 0.97 as our final value. So the probability that he would pass physics or the French exam would be 0.97 or 97%. Now let's take a look at question 3. Of the works of art at a large gallery, 60% are paintings and 85% are for sale. We can assume both events are independent. Since they are independent, you may use the multiplication rule. I'm going to walk you through the first step in solving this problem, and then I'll give you time to complete solving the problem. First step is to convert percents into decimals. So 60% becomes 0.60 or simply 0.6, and 85% becomes 85 hundredths or 0.85. Please remember that a probability could be expressed as a fraction, as a percent, and as a decimal. If probabilities are expressed as percents, you must convert them to decimals before you can start your calculations. Now you may proceed in completing the problem. Thank you.